Hello, my name is Kristina, and today we are going to talk about Node.js testing and how to write tests following best practices. I want to talk a little bit about me. I'm a senior software engineer with experience in web development, and my main expertise is Node.js. I also had experience working as team lead. I am from Ukraine, but currently I live in Poland. I also have 2 small dogs and I love fashion. That's all. A little bit about our presentation plan. So we will talk about why do we need testing, where should we test our application, how the test should be structured, generic best practices, and tools to improve testing. So first of all, I want to talk a little bit why I choose this topic. For me, this topic is very important because every time when I came to company, I see a lot of issues with tests. For example, people write tests using different styles, or they write dummy tests, or they make mistakes writing tests. So after seeing this over time, that every project has these issues, I decided to create this presentation to teach people how to write tests properly and following best practices. I think this seems like introduction to this topic. It's actually very broad and wide, but I will talk only about like surface topics, just so it I will show this to like broad audience, and I think mostly it's for beginners, but I think even like people who are here for a long time in programming, they will benefit from this presentation. So first of all, quickly go through the goal of testing, because I just can't not mention that. So the main goal of the testing is to build dependable and reliable software. It's to discover bugs, to build quality software to make our customers satisfied with experience and with our work, and reduce maintenance cost. So as you know, all programmers make mistakes. It could be because of time pressure, especially if you work in startup. It could be misunderstanding over requirements. For example, because you didn't understand your manager, or it was miscommunication between some parts. It could be because of incorrect requirements or complex infrastructure, unexpected conditions, or complex existing code. And according to Steve McConnell Code Complete book, averagely we have from 15 to 50 bugs per 1,000 source lines of code. Yeah. Here I want to talk about common mistakes in Node.js application. So the most common mistakes are, give me 1 second. Common mistakes are floating point numbers, numeric limits and boundaries, complex Boolean expressions, casts and conversion between types, and blocking the event loop. So let's dive into those topics and talk more specifically about every part. So first of all, floating point numbers. Usually it's a problem for large-scale scientific type software. Usually Node.js, we don't use Node.js for these types of application, but still sometimes we use floating point number conversion, computations, comparisons. And as we know that we have infinite number of real numbers, but finite number of floating point numbers. So it means that they are imprecise in our application. And it became a problem when we do comparisons or computations, and more or less you like closer to 0, the more or less imprecise it becomes. So this could be the point of failure in your application, and you should be mindful about that. Next one is numeric limit and boundaries. So it happens all the times. It could be because of issues with requirements, or some low-level issues like buffer overflows or something like that. For example, you have a condition cycle that you should go to 100 specifically to 100, but you go above or below 100, and it also could be point of failure. Complex Boolean expressions. I think everyone saw in the application like really huge Boolean expressions, if, and, or, and you sometimes you even don't understand when it should be true, when it should be false. So if you see this kind of expressions in your application, you should really closely test this. Cast and conversion between types. So it usually happens when you convert one type to another. So for example, you convert from floating point number to integer, and you can make the value less precise because of that, because you can do it in different ways, right? You can do it with different methods that exist. Also in JavaScript, floating point numbers can contain integer representation only to certain level. And in JavaScript, like floating point numbers, you can use integer calculations using floating point numbers. So it also could be point of failure. And also regarding Node.js, it could be issue if you're blocking the event loop. So if you're using a lot of JSON parse, JSON stringify, you're using bad regular expressions, or you're doing long sync operation, for example, reading files synchronously and it's long, or you are making a CPU intensive operation, for example, you're using crypto module, this could be also issue in your application, and you should be pay attention to that part. So I think everyone knows about Pareto principle, 80-20 rule. So actually in programming, it's the same, and in testing, it's the same. So the small number of modules usually contain most of the bugs and defects. Usually you need to pay attention to the parts where the business logic, and the more business logic you have, there you should pay your attention more closely, more precisely. So next one, let's talk about types of tests. I think everyone knows about that, but I just briefly go through all of them because I think it's important for this topic to talk about different types of tests and how we should use them. So first of all, unit tests, it's the unit test. We test with unit tests like smallest functions, smallest methods that our program have. So it's the most simplest test to write, and it's the cheapest test to write. Next one is integration tests. Integration tests, we are testing modules. When modules are how modules interacts with each other, how they combines, and this is integration testing. Also, we have functional testing. It's then we have, for example, we have endpoint, and we want to test endpoint from beginning to end, till end. So when user hits that endpoint, and when we interact with database, Redis, or everything that we have. And usually in functional tests, we have dependencies. So we need to have like some kind of Docker compose that scaffolds all our database, our Redis instance, everything that we need for real application to work. So it's a little bit different than integration tests, because in integration tests, we shouldn't scaffold the database and all of that. We could only test modules, how they interact with each other. Though in functional tests, you should do all of that. End-to-end tests is when you test your application as a user from end-to-end flow, like user flow. So you, for example, have front-end application, back-end application, and you start testing from user going to website, clicking some button. Then it sends request to backend goes to database, and with end-to-end tests, you're testing the whole user flow. Acceptance testing is when, for example, your manager comes to you and says, I want this feature to work like that, and it gives you If user do that, then it should be that. This is basically acceptance testing. And I will show you later how we can do that in our application. Performance testing, I think everyone knows, is just to check the performance, how application performs, what is their like scalability, availability, how it performs under different kind of loads. Not only our application, but it could be like our database, everything. And smoke testing is when it's usually done by QA. It's when QA tests very quickly after you release a feature, checks that everything works properly, like base functionality. And here, as you can see, I don't know if you see, this is like test pyramid. And as you can see, the unit tests are the cheapest one and the fastest. And UI tests are very expensive and slow. So we preferred in our application, you should always have unit tests. Then second, you should have either integration or functional tests. But unit tests are like base one. You should 100% have them, at least unit tests. And then you could think about other types of tests. For example, on my experience, we usually had two types of tests, which is unit tests and functional tests. And it's usually enough to cover like different scenarios in your application. Okay. So next, let's talk about naming standards for tests. So the test should follow and should answer three main questions. What is being tested, under what scenario, and what is expected result? So test name should express a specific requirement, business or technical, and everyone should understand what failed and why it failed. So I will show you right now examples of bad naming and good naming. So for example, here, we know that we are testing user location service. And it says, can't return country code. But from this name, we don't understand under which circumstances it should return, what we are testing. Nothing is understandable. Next one. Get country code from user phone should return primary country code successfully. It's better, right? But we know what we are testing. We test in method get country code from user phone. And we know that it should return primary code. But why? But why primary? Like, why it should return primary? We don't understand this. Next one. This is, I like this name because I see this a lot, like honestly. Get country code from user phone should throw error. Like why it's throwing error? Also, we don't understand this. Let's go and check the good naming for tests. So we know that we're testing user location service. We know what method we are testing, get country code from user phone, and it's in its own describe, as you can see. And we say should return country code by primary phone if phones is array of few phones. So it's basically returning country code by primary phone if it's array of phones. And now we understand why we return primary phone, what is expected result. Yeah, you could also use different format like when phones, array of phones, then primary phone should be returned. And in case of this, you should specify which error, what error failed. For example, should throw validation error if I don't know, phone was not provided, and it should be like that. Okay. You could also use given when then Gherkin format. It's usually it's often used by QAs and managers when they give you, for example, requirements for your feature, and you can get these requirements, put it in your tests, write them first, for example, by requirements. Then after that, write your code and then check that it all requirements were passed. And if something fails, someone rewrites your feature, you will know that all requirements that manager gave you like some time ago, they still working fine and properly. And usually it's the acceptance testing. I talked about it earlier. And usually people use it when they want to check the not behavior application, but state of application, how state was changed. And for that, you can use libraries. For example, I prefer using Jest when I test my code. So we have Jest Cucumber library that you can use, but also there is Cucumber.js library, which also you can use if you use something else. Next one, structure test by AAA pattern. I hope everyone knows that and used it, but just a reminder that test should be followed by, should have all these three sections: arrange, act, assert. So in the arrange part, we create some data, mocking, stubbing, everything that we need to make test work. Then we have act part, which is usually one line only, which is basically calling function or doing what we need to do. And then we have assert part, which expects the result. As you can see, this test, very easy to read, very easy to understand, and it should be separated by spaces. So a good unit test is that simple. It tests only one thing per assertion, and it has absolutely no magic. Yeah, let's talk about assertion. So each test should check exactly one thing. So I often see, I'm not saying that you should have only one expect always. Sometimes it's even not possible. But I often see that people write a lot of like tests, a lot of expects. They have a lot of expects in their tests, like 5, 7, I don't know. And sometimes they check different behaviors in one test. And I don't think it's a good practice because your test should follow also like single responsibility principle and should test only one thing, check one thing only. So this is like dummy example because I created it. But it's basically checking that some method should send SMS with provided phone and emit event. We can split this test to two, which is should send SMS with provided phone by calling SMS sender, and should emit event SMS sent if SMS was sent successfully. In this case, it's easier, if something fails, it's easier to understand what fails exactly, and it's easier to fix and simpler to read. Okay, so use realistic input data. We have different libraries, Faker and Chance. In this example, I use Chance. So basically, it's better to use realistic data always. Why? Because it's just closer to what exactly you save to your database, what exactly users input. Because if you don't use that, you're basically making artificial tests, and it could lead to bugs because you could miss some bugs because of that. Avoid global text features and sits at data per test. So it's actually common mistakes. I don't know what about you, but I see this a lot. Then people create one object of user, of game, I don't know, of something. They create only one object and then reuse it across multiple tests. It's bad practice because one of your tests could change the data, which could lead to other tests failing. And you will spend a lot of time not understanding why the tests the code you didn't even touch failed. And it could be because of reusing data. So it's like best practice to use always data per test, always create new data for every test. And we have libraries that could help us with that, which is Factory TS and Fishery. In this case, I use Factory TS. it's basically you create factory once, and then every time you build it, it creates a new instance and creates new object. You can reassign values. You can provide different values that you want. And for example, if you have like very huge object, nested object, you can reassign one field and all other fields will be the same as you provided in your initial factory. Also, you can create lists and a lot of, you can check the library. It's very great. I like this library. Honestly, we use this library. And it also can generate data for you and do a lot of stuff. Next one, choose data cleanup strategy-wise. So this is more for functional tests, I think, because for unit tests, it's not that important, but for functional tests, it's very important. So there is generally speaking two cleanup strategies: to clean after all tests and to clean after each test. So for example, you want to test something with database. You create some data, you save it to database, and then you expect that what you saved, you get something from database and you expect to see what you saved. For example, like this dummy example. And if you clean your database after each test, it makes your test artificial, because in reality, in real environment, you will never have empty database. It always be full with some kind of like tables, records, like everything. Also, you can have with this approach, with after each approach, you can have parallel run issues. So for example, one test tries to save something, at the same time another test tries to get something, and it could have potential issues. But it's easier to write tests because you know that it will be always empty, it will be from empty state, and you can always understand. But it means that you can have bugs that you don't even see because of this approach. Another approach, after all, when you write in tests in such a way that you, it's okay to, then they work in parallel. It's okay, then you save the data, it's already data in your database, and it's more realistic. It's more easy to troubleshoot, and it has better performance because you don't clean everything after each test. So like everyone recommends using after all approach. So if you didn't try it. So let's talk about other generic best practices. So first of all, I hope everyone knows, test only public methods. Please do not add logic inside your tests. Sometimes I see like for loops, if in tests. Please don't do that. Tests should be that simple, as I said, and we don't want code in our tests. Don't catch errors, expect them. Sometimes you might see issues if you're using try catch. For example, you have this method called and you expect some kind of errors, but if this pass and will not throw an error, you need to add additional fail method here just to make your test work. So it's better to like expect error and use the expect error approach in this case. Also, try to use test-driven development if you can. Do not add tests only to make coverage happy. So sometimes I see, for example, you have some class that make call to another service, external service, and it just simply makes call, like fetches some data. And your coverage is not happy because you didn't touch that code, right? And sometimes I see people write tests that they mock this call, then expect this call to be what they mocked. It's like a very dummy test. So better approach for this would be to write functional tests, which will test all your flow and touch this part. Check the response schema. It's always like a great way to test the response schema of your endpoint. Especially you need to check required fields that you return. And I know there is like extensions, some tools that help you to do that. For example, Swagger has this, it has extensions that can help you to check if it actually, what you return is actually equal to what in your Swagger documentation. And always test outcomes, so what your API returns, like some observability stuff, if state changes, like everything. Always, I think maybe, I don't know if all companies use this, but a lot use static analysis tools like SonarQube or Code Climate, which help you to reduce bugs. It will check your code security for maintainability, and early tell you if your code is good or not. Mutation testing. This is a very interesting thing. Sometimes your test coverage is lying, because what test coverage saying to you is that you only touched that part of code. If you have like big if you touch some part of it, it will say the line is covered. So you could be fooled to believe that you have 85% of coverage, but it doesn't mean that you detect all the bugs. So for this, Striker exists. This is library called Striker, which helps you to check those things. How it works? It basically planned a mutation. So for example, you have this, for example, you have if with this new order price equal to 0. And you thought that you tested it, everything is fine. But what Striker do, it plans mutation, it changes your code to make new order price not equal to 0. After that, it runs all your tests. And if test failed, great, you kill the mutation. If all your tests passed, then you have a problem. It means your tests, like, they don't check that condition properly. And it especially could be good. Remember, I talked about like a lot big if statements, big Boolean expression statements when you have a lot of or and. This is great tool to test, especially that, and it could be a great tool for that. Preventing test code issues with test linters. So use test linters, for example, ES plugin Jest. For example, it could check, help you to check those best practices that I talked about. For example, it could check that test has no assertion at all. It could check that you don't have conditional logic, and you can like configure it as you want, as you wish. And test for node-related chaos. So chaos engineering was born by Netflix. They created the chaos monkey that randomly kills servers to ensure that they still could serve their users. Also exists library kubemonkey, that it's like Kubernetes version of that, and node chaos that provides all sorts of node-related chaotic behavior. And of course, make your life easier. Use ChatGPT, use GitHub Copilot to help you write tests. It's very easy to do. I don't know if how many people right now use it, but basically, for example, Copilot, you can write a command. And then under that command, click and ask Copilot help you, and it will at least create the base for your test. You could choose the tools that you want to use, and it will it's actually increase your productivity a lot. But I think it has some problems. I think if you have like have NDA, it could be very difficult if you, for example, get code from your company and put it in ChatGPT. It could be issue because it basically learns using that code. So be mindful about that and be careful. And here are the links I provided for you, what to read next if you want to dive deep more into this topic. For example, Martin Fowler has a few articles. One of them is Practical Test Pyramid. If you're using microservices, it would be a great read for you to read about microservice testing. Also, I like this man, Khalil Stemler, which talks a lot about use case testing. Also, a lot of information I got from this repo, which is JavaScript testing best practices. And also Google has their own blog about testing, which you can also read. And also I wanted to say that why I did this presentation. I think I forgot to say this because, no, I said this, sorry. Okay, so I think that's all. I hope it was helpful and thank you for your attention. If you have question, please ask.
Okay, so yeah, we have several questions in the chat, but still we have one raised hand. So maybe we should start from this and then be back to chat. Artem, hi.
Hi, can you hear me?
Yeah. Hello.
Yeah, I have such question regarding microservice testing. So I would like to try to describe the situation I have currently on project. So we have a mobile application which has
you have
a
what?
dedicated.
You have what? Sorry, could you repeat?
A mobile application.
Mobile. Mm-hmm.
Which has dedicated backend service for it.
Mm-hmm.
And also we have some microservice that is only accessible from the scope of backend service that I've already mentioned. So the question is the next: when we are writing functional tests for this backend for frontend service, are we supposed to mock other microservices, or is it better to actually make real calls?
No, it's better to mock calls to other microservices because you don't want to change your test every time you change something in that microservice. It's more suitable for, I think, end-to-end testing, using end-to-end testing to test those types of applications. But also, I read some article where you can you can read about it called contract testing, where you can write specific tests for other external services that you are working with, to not have issues if contract breaks and you have so not have such issues, then something changes on that part. But I think you should mock for sure.
Yeah, and I have a following question. So you mentioned end-to-end tests, and do you mean the ones that actually check what is being shown to end user?
Yeah.
On the phone screen?
Yeah.
Okay. And do we have some approach like intermediate for that? So kind of without checking which values are displayed on for the user, but actually testing the whole system, like regardless of its microservice structure.
I think honestly, I think you can use end-to-end testing even like without showing it to the user. I think you can just call the API and use the API to test it.
So the test that actually checks the responses, for example, from REST API is also called end-to-end, right?
Yes.
Okay, got it. Thank you.
Okay, so now we can be back to the chat, so you can I think from the start check everything.
Okay, chat. Could I stop sharing the screen?
Yeah.
Okay. I guess. I think Faker exists, but it's just someone else decided to continue to maintain Faker.
And please, can you read out the questions?
Oh, okay.
We'll have it on the video.
Faker is no more, I guess. So as I said, I think someone else, I checked, someone else maintains the Faker now. As we use TypeScript here, when our methods have interfaces, why do we still need this info like arrays of arrays in our test descriptions? So it's just for you to understand. It's not like you need to write arrays of arrays or something like that. It was just an example. It just was to describe that you need to describe your test more precisely, like under what circumstances it fails. Not only write what should it do, but why it failed or why it should pass, because of what conditions, by which conditions, basically. I hope it answers your question. What tools, libraries could be used for acceptance testing and performance testing? Okay, so for acceptance testing, I mentioned you can use the Cucumber.js. And for performance testing, we use K6 library. But honestly, I haven't checked other libraries, but we use K6 and it's really, I like it. It's great library. You can like use different algorithms there, choose different different loads, type of loads. For example, if you want exponential load or you want flat load, check that library.
Okay, we also have a raise hand again from Artem, the guy who was with us. Give me a sec. Okay, Artem, hi again.
Yeah, hi again. So now my question is regarding K6. So when we were introducing it on current project, we figured out that it doesn't support Node modules. So it was a challenge dealing with such tasks as, for example, creating authentication tokens for our headers. So did you find any helpful trick to overcome this limitation, or we are supposed to just use the native tools of K6 for such tasks?
When you're saying you couldn't use Node modules, what do you mean?
I mean, if you use K6, basically it doesn't use Node.js, for example, to run these cases. It's just another version of JavaScript interpreter they use that doesn't support required and import statements, because they're running it not in single thread, but instead of in many threads, which is possible only with C++ or other languages. But never mind. So the main limitation of K6 is basically they do not allow to require anything besides something that is inbuilt, something that is provided by K6.
Honestly, I don't know. I didn't dive that deep into that question, but I can check.
Sorry.
I can check if you need, really.
Yeah, then never mind. Thank you. Yeah.
Okay, let's continue. As per my understanding, when we try unit testing and we are testing a specific function to the same fake data to process within the function and return some result, we need to send the data. Sorry, I didn't get the question. It's the answer to the previous question or what? Okay. Could you talk about more about Node.js, how it can be used? Yes. So, for example, you can like what it does. This library, it could, for example, block your event loop and check how your application behaves. It could check your API. What if you have like a lot of errors, for example, how your application will behave, or how your system behave on different type of failures, and like does it like send some alerts or how it behaves. Thanks for a report. You're welcome. How to test threads on data mutation that logs in Node.js, any libraries? Honestly, I don't know. I never tested that, but I will check. Thank you for the question. Do you run some test suite in the static environment like dev or QA env? And if so, how do you clear the testing data? Yes, testing data. So like usually like libraries, so you have like after each, usually like libraries provide some methods to clear that. But if you're talking about the data, if you, for example, save something to database or save something like to Redis and you want to clean, so you can use like basic methods like just request to database, just request to Redis to clean that data. But for example, in my current project, we are using after each strategy where we after each test, we clean all the data from database, from Redis, if we are talking about functional tests. But I prefer, as from my research, it's better to use after all strategy when you clean all the data. So you see the data before the test, then you do the tests, and then you clean all the data. Does the rule of AA could be in the list of the best test design practices? As I know, Gherkin-based frameworks makes you writing tests with the same pattern. Yes, yes. It's in the list of best test design practices. I don't know, maybe you can get my presentation. I added some links that you could read. And by the way, Artem, maybe like in Martin Fowler microservice testing, you can also find your answer.
Yeah, I'll send slides together with video recording. So yeah, guys, you will have the slides so you can use these links.
What do you recommend for IT security testing? I never touched this topic about security, like how to test for security. So I don't know. As Striker module adds mutations to the code, where does it change at the mutation? Where does it change at the mutation? So it finds, for example, your if statements and just plants the mutation, changing your code, and then run tests. Pen test, scanner, itself for security. Okay, thank you. Someone answered you. You can use penetration testing and for security. Yeah, and by the way, those tools that I provided, like Code Climate, they also allow you to see like some security issues. If you use those tools, it should help you for sure.
I suppose it's not the answer, but I think it's common because Alexei is the same person who asked this question about security testing. And I think it's like additional comment. So maybe you know something about this. Like, for example, I mean, Alexei asked about this. What do you recommend for IT security testing? And he commented to his question.
Okay. Yeah, as I said, you can use those tools. At least this is what I know, but that could also help you, like to scan your application for security issues. Code Climate and I forgot the second tool, but you can see my slides. Should I worry about NDNA when using Striker module? I don't think so. Like it means you need to worry every time you like. Every time you use any external module, you should worry about NDA check the module itself. But usually if it's well maintained and it has a lot of users that you're using it and it's maintained by community, it should be fine. You could use joylib to validate any incoming data as well. Okay, thank you. Thank you for the suggestion, Denise.
So friends, any other question in the chat, or maybe you want to raise hand? We have a few seconds to do this. And Kristina, during this time, you can think about 3 winners.
Yes, for sure. Okay, so I like the question about tools. Libraries could be used for acceptance testing and performance testing by Andrei.
Can you see the name? Yeah.
Andrei Sova. I also like question by Yaroslav, though sorry I couldn't answer. Yaroslav Rajila. Sorry if I don't pronounce it correctly. I remember one and about penetration testing. Alexei. Oh, Artyom, I want to also.
Okay, we can give four gifts. It's not a problem. Alexei, just please write me maybe personally about your family name, because I need to find you somehow from other Alexeis of participants. And we have two more questions. We have one question. Oh, three more questions. Oh my God. What you can suggest for load testing?
Yeah, I already said that, for example, in our project, we're using K6 library. What approach do you recommend for test-driven development? So if you want to just to start, I know it could be difficult to start to use the test-driven development. So my suggestion would be to start doing this only on bugs. So for example, you have a bug and that you need to fix. Don't go right away and fix the bug. Find where it is, then write test for that bug that covers that bug, how it should behave in reality the system, and then write the implementation and check that your test is working. It's just easier for you, would be easier for you to start to understand how it works and get, yeah. What the approaches you use if you have 1,000 tests or more? We have more than 1,000 tests. We don't use any like specific approaches. You mean like your tests are too slow or what? Like run tests in parallel. It could be a good practice for you to run them in parallel to make it faster. Yeah, so I don't know. Answer clinic plus autocon follow testing. Yeah, thank you, Ramis.
Okay, so maybe other questions. A very active audience we have today. I'm very glad to see so many questions. Thank you, guys. So seems like no more questions. Okay,